My name is Omar Ataway and I'm going to be explaining a past IB Physics Paper 1 Topic 3 question. So in this question it says that an ice cube and an iceberg are both at a temperature of 0 Celsius. It says which of the following of these options is a correct comparison of the average random kinetic energy and the total kinetic energy of the molecules of the ice cube and the iceberg. So one notable thing about this is that they both share the same temperature. They both share a temperature of 0 Celsius. Another thing you should note is that there's a difference between the average random kinetic energy and the total kinetic energy of the molecules. This is different than this. Now, the first key point you should know is this. Which has more mass, an ice cube or an iceberg? Now, of course, an iceberg has a lot more mass than an ice cube, but you may be questioning why I'm mentioning this and its relevance to the question. Now, to find the average random kinetic energy, use this formula, which is the formula for it, which is 3/2 times Boltzmann's constant times temperature. Boltzmann's constant is just a constant, meaning that it's a gas constant divided by Avogadro's constant, so it doesn't change. And the temperature is the only thing that changes here. So since both the ice cube and the iceberg share the same temperature, then they also share the same value for T, or temperature, in this equation. So since these are constants, and this is also a constant, then if they both share the same temperature, then if you plug in the values for this equation, you'll get the same average random kinetic energy for both. So this eliminates option C and D immediately. Now you're left with option A and B. Now what is the total kinetic energy of the molecules? Total kinetic energy of the molecules means that you take the average random kinetic energy and you multiply it by the amount of moles and the amount by the amount of moles and by Avogadro's constant. Now, you have to know that mass is proportional to moles. So if the iceberg has a greater mass than the ice cube, then the iceberg will have a lot more moles than the ice cube. Therefore, when you multiply the average random kinetic energy of the ice cube by its moles and then by Avogadro's constant, it will have much less of a lower value than the value of the iceberg, as the iceberg will have a lot more moles. So if you multiply the amount of moles of an iceberg by its average random kinetic energy and by Avogadro's constant, you'll get a much higher value for its total kinetic energy of its molecules. Therefore, your answer is A, because your answer is B. I'm sorry. Your answer is B, because they both have the same average random kinetic energy, but they have different total kinetic energy of the molecules, because an iceberg will have a lot higher value for the total kinetic energy of its molecules compared to an ice cube. So that's your answer for this question.